Optimizing composite structures is done during many stages of a project, from early conceptual design all the way to the detailed analysis stage. In this video, I'll talk about a typical design and analysis workflow we may utilize, the various stages involved, and the benefits of this methodology. This example will be based on a motorsport composite part we designed using synthesized composite material properties. So, firstly I'm going to perform some geometry changes to the part. Here I'm simply increasing the radii size to allow for better stress distribution. This is all done in the CAD stages of the model. In this case I'm using synchronous modelling techniques, which is a quick and efficient way of making small CAD changes. The FE model is linked to the CAD model to allow for good associativity when making changes. The next stage will be to perform mesh updates that reflect the changed geometry. To the left of the window, the various meshes in the model are shown using mesh collectors. These flag up when an update is required. If the geometry changes made are simple enough, we should only need to click the update button at the top. Once this is clicked, the software will automatically remesh the required areas to reflect the geometry changes. Here we can see those meshes update accordingly. After this, we can move on to the finite element analysis. To do this, we need to resolve the solution with the same boundary conditions, which has already been done here to save time. This animation shows the stress distribution results when the structure is fully loaded. As can be seen, the high stress area is at the pockets where we made geometry changes earlier. This example is failing in shear. Moving forward, we could either make more geometry changes, or, because this is composite, we could make layup modifications to improve the structural performance. In this case, we'll look at making changes to the layup and resynthesizing using composite layup design and analysis software. As the area of concern was high in shear stress, I'm changing the 0 degree plies to 45 degrees. After this is done, we simply click the solve button in the laminate module, which synthesizes the stack, giving us new stiffnesses and strengths. These can then be reapplied in the FE model. So, as shown in this example, with the use of good design and analysis model associativity and utilizing material synthesis techniques, we have the ability to optimize composite structures quickly and efficiently. At Frewer Engineering, we have also developed novel scripting techniques. These are utilized when highly complex layups need to be structurally assessed, for example filament wound structures. Our scripts can take raw manufacturing data and convert them for use within NX Nastran, keeping all composite properties and orientations intact. Not only does this allow seamless transfer of data, but if the geometry is too complex, requiring 3D elements, our scripts can also handle this. Thanks for watching, and remember to check out the Frewer Engineering website for more information on our composite capabilities.